Hello Year 12 and welcome to Purple Mountain Maths. Today we're doing the 2025 HSC paper for Maths Standard 2. This is part 6, covering questions 30 to 34, covering 16 marks. Question 30. It costs $465 to register a passenger car and $350 to register a motorcycle. Let P equal the number of passenger cars and B equal the number of motorcycles. Write two linear equations that represent the relationships below. There are 11 times as many passenger cars as motorcycles, and the total registration fees for passenger cars and motorcycles is $494 million. Pause here to try yourself. Okay, so if there are 11 times as many passenger cars as motorcycles, we know that P is much, much bigger than B, and in fact P is 11 times B. And so our first relationship is simply that, P equals 11 times B. The second relationship relates to the cost. The total registration fees will add to $494 million, but we know for each one of the P's it'll be worth $465. So 465 times P is the amount of money we get from registering passenger cars, and $350 times the number of bikes will give us the registration fees from the motorbikes, and they together will add to $494 million. So we'll write that in dollars, and that is our second relationship. Question 31. The table shows the income tax rate for Australian residents for the 2024-2025 financial year. And we have a standard table as shown. At the end of the 2024-2025 financial year, Alex's tax payable was $47,420, excluding the Medicare levy. The question says, what was Alex's taxable income? Pause here to try it yourself. All right, so let TI equal the taxable income that we're looking for. We know that how these equations work is that if the tax payable was $4,420, we must be working in this row of the table. So 31288 plus 0.37 lots of TI less 135,000 must equal our answer of 47,420. So we can tidy this up a little bit by subtracting that 31,288 from both sides. We can do that in our calculator. 47,420 less 31288, we get 16,132. We can divide that by 0.37. So take that answer and divide it by 0.37. We'll get 43,600. And we can add 135 to that. 178,600 must equal the taxable income, and that's my answer. Question 32. Solid spheres are placed inside a square-based pyramid as shown. The base of the pyramid has side lengths of 14 centimetres. The height of the pyramid is h in centimetres. The radius of each sphere is 1.5 centimetres. The amount of empty space remaining inside the pyramid after 30 spheres have been placed inside is 634 cubic centimetres. What is the height h of the pyramid? Give your answer correct to the nearest centimetre. Pause here to try yourself. Okay, so I know that the volume of any pyramid equals a third AH, where A is the area of the base. So in this case, it's a third of 14 squared times H. I can put that much into my calculator. 14 squared all over 3. I get 196 on 3 lots of H. So that's the volume of my pyramid. I know that the volume of any sphere equals 4 on 3 pi r cubed. So the volume of one sphere in this case is 4 on 3 pi times my radius is 1.5. So let's work out what that is. 4 over 3 times, I'm just going to leave it involving pi, so I'll just work out the 1.5 cubed. So that is 4.5 pi. So that's for one sphere. But I do know that in fact there are 30 of them. So the volume of 30 spheres is 30 times 4.5 pi. So that number times 30 is 135. So the volume of 30 spheres is 135 pi, and the volume of my pyramid is 196 on 3h. We know that the difference between these two things has been given to us as 634. So let's set up that equation. So the volume of the pyramid less the volume of 30 spheres is given to us as 634. So 196 on 3 lots of H less 135 pi equals 634. So now we're just solving for H. So 196 on 3 lots of H must equal 634 plus 135 pi. So H equals 196 of whatever that adds up to. And I glance at the instructions. They're inviting me to give my answer correct to the nearest centimetre. So I can go ahead and calculate all that now. 3 over 196 multiplied by, open bracket, 634 plus 135 lots of pi, close bracket. I get 16.1956, 16.1956, and so on. And I need to do it just to the nearest centimetre, so it's approximately 16 centimetres, and that's my answer. Question 33. A used car has a sale price of $24,200. In addition to the sale price, the following costs are charged. There's a transfer of registration fee of $50. There's stamp duty, which is calculated at $3 for every $100 or part thereof of the sale price. Cat borrows the total amount to be paid for the car, including transfer of registration and stamp duty. Simple interest at the rate of 6.8% per annum is charged on the loan. The loan is to be repaid in equal monthly repayments over 3 years. Calculate Cat's monthly repayment. Pause here to try yourself. Okay, so the first thing we need to do is work out the total amount that's going to be paid. So the total amount is going to be the purchase price of $24,200 as well as $50 which covers the transfer of registration, plus we're going to pay $3 for every $100 of the sale price. And I notice it's already a factor of 100, so this is going to work. I'm going to throw all of this in the calculator. 200 plus 50 plus 3 lots of 200 over 100. So I get 24976 as my total amount. Now let's work out interest. Interest equals PRN equals 24976, and the rate is 0.068, and the number of years is 3. So I can put all that in my calculator. That answer times 0.068 times 3, I get 5095.104, 5095.104. So I must pay both the principal and the interest. So I must pay principal plus interest. So I'm going to pay 24976 plus 5095.10, and I can put those in my calculator. That answer plus 24976. I'm going to get 30071.10. That's what I must pay, and I'm going to pay it in monthly repayments over 3 years. Now note, 3 times 12 equals 36. So I'm going to have 36 equal payments. So each payment is that amount less over 36. So let's work out what that is. Divided by 36, I get 835.31. And that's my answer. Question 34. The table shows future value interest factors for an annuity of $1. As shown, Lynn invested a lump sum of $21,000 for 7 years at an interest rate of 6% per annum, compounding monthly. Yemi wants to achieve the same future value as Lynn by using an annuity. Yemi plans to deposit a fixed amount into an investment account at the end of each month for 7 years. The investment account pays 6% per annum, compounded monthly. Using the table provided, determine how much Yemi needs to deposit each month. Pause here to try yourself. Okay, let's work out what's going on for Lynn first of all. So that we know that Lynn is dealing with an interest rate of 6% per annum, compounded monthly. So we always look for the adverb. We look for the word that ends in the letters ly, because it is an adverb. It is a describing word on a verb. It's telling us how often the compounding is occurring. The fact that it says monthly means we must work in months. We need to convert our n into months. We need to convert our r into months. Let's work out the r first. So the r of 6% per annum is going to turn into 0.06 over 12, which is 0.005 monthly. Similarly, I need to deal with the n. The n, which was 7 years, needs to be turned into months. 7 times 12, which is 84 in months. Okay, so now I'm going to use future value equals present value 1 plus r to the n. So I've got 21,000 being invested at a rate of now 0.005 raised to the power of 84. I can put all of that into my calculator. 21,000 times, open bracket, 1.005, close bracket, raised to the power of 84. I get 31,927.76. So that's the future value that Lynn's going to achieve that Yemi is also chasing. So let's see what Yemi's doing. Yemi plans to deposit a fixed amount of investment account at the end of each month for 7 years and also compounding monthly. So we're also needing to deal with months for Yemi. So Yemi's situation over here has the same R of 0.005 monthly and the same N of 84 months. So now we need to consider the table. So 0.005 means we're dealing with this column, and 84 means we're dealing with the last row. So the table value, which is very important for us here, table value equals 104.07393. Now the way we use these tables is that the future value equals the table value times the contribution. And in this case, we know the table value and we know the future value. 31927.76 equals this table value of 104.07393 times the contribution, which we don't know. So the contribution must be that future value divided by the table value. Take care to write that down super carefully. So it is that future value number I had before divided by 104.07393. 393. Take care to write it down really carefully. Okay, so I get 306.78 contribution is 306.78 in dollars, and that's my answer.